Hello and welcome to my presentation on Carbyne complexes. So we're going to start with what are Carbyne complexes. They are an organometallic compound that is containing a metal carbon triple bond, which you can see here in the general formula. Now there's two types. One is the Fischer complex, and here's an example. And here's a Schrock complex right here. Now these two are going to be used throughout the presentation further on for things like synthesis and reactivity. Along the bottom you can see a reference which you can go to if you would like some more detail on this topic. So, the synthesis of carbene complexes. The general reaction is that this double bond here between the metal and the carbon goes to a metal carbon triple bond, and as you can kind of tell, one of the R groups is lost in the process. A common method for this is alpha hydrogen abstraction. So early D block metal complexes containing one or two alpha hydrogen atoms can undergo alpha hydrogen abstraction. So an example using a Schrock complex, if we react a Schrock type complex with trimethyl phosphane and methylene triphenyl phosphorane, this results in the exchange of one of these Cls for a PME3 and the removal of this hydrogen here. This forms this Carbyne complex here, and the alpha hydrogen abstraction has taken place. So the method for using the Fischer carbene complex can be seen here. Now this results in the exchange of a CO ligand for a halogen, and the methoxy group here is abstracted to form the metal Carbyne complex that you can see here. Now for this triple bond, there's one sigma interaction between the metal and the carbon, and this occurs between the sp-z orbital, while the 2 pi interactions use the carbon's 2px and the 2py orbitals, which overlap with the metal's dxz and their dyz orbitals. This triple bond, or pi back bonding, or can be considered as pi back bonding, from the metal into the pi accepting orbitals on the Carbyne. Now, here's a little journal article that you can go to if you want to see some more on the synthesis. Now for the reactivity. The triple bond between the metal and the carbon in the Carbyne complexes can have different reactivities depending on the type of complex. So, in a Fischer Carbyne complex, the Carbyne carbon will show some electrophilic behaviour. This means it would be more prone to an attack from a nucleophile. However, in a Schrock carbene complex, the triple bonded carbon exhibits some nucleophilic behaviour, so it does the opposite and it's more prone to attack an electrophile. The metal triple bond can undergo addition reactions to form catalysts. Now here's an example. If you react this Carbyne complex with HCl, you form this carbene complex, which is also known as Grubbs catalyst. And just in case you didn't know, the C6H11 here is called cyclohexyl. Now, metal carbine carbonyl coupling reactions can also occur. This is where the carbonyl ligand shifts over onto the carbyne, eventually forming a ketene group, which can be seen here. So as you can see, it forms this almost like bridging carbon between the metal and what was the carbyne carbon, and then it fully shifts over and it forms the ketene group. Here's a journal article which speaks a bit more about the carbonyl coupling reactions. Now we move on to applications and uses. So the most common use of metal carbene complexes is to form catalysts, and the first example is this Grubbs second generation catalyst. There is a third, but you can go to this reference here and find it in the book. And the second example is a Schrock type complex. Now if you didn't know, MES stands for mesitylene, which looks like this, And these catalysts are most often used in organic synthesis and most commonly alkene metathesis. Now, this is also known as metal catalyzed reactions where the double bonds are redistributed in the molecules. There are 4 types of this metathesis: cross, ring opening, ring closing, and ring opening polymerization. And the example shown here for metathesis is cross metathesis, where these 2 alkenes react together and then they form these 2 products, and as you can see, the double bond has been redistributed and the R groups are now placed on different molecules. The other reactions that metal carbyne complexes can be used in are photochemical reactions or coupling reactions with isocyanides.